Patient for an oxygen control system using IoT. Abstract: improving quality of life is one among the most benefits of integrating new innovations into medicine. Medical technologies such as less invasive surgeries, proper monitoring systems, and better scanning equipment allow patients to recover soon and enjoy a healthy life. For good patient care in hospitals, assessment and management of patients' fluid and oxygen need is the most fundamental thing required. The patient history will also be helpful if stored in the hospital's database. Almost altogether, hospital, an assist/nurse is liable for monitoring the saline fluid level and oxygen level continuously. But unfortunately, during most of the time, the observer may forget to change the saline bottle at correct time due to their busy schedule. This may lead to several problems to the patients, such as backflow of blood, blood loss, drop oxygen level. The design and implementation of patient for fluid and oxygen flow controlling method employs liquid flow sensor, pressure sensor, and pulse detector sensor. The microcontroller, node MCU, are presented here, which has the ability to assist the healthcare provider to control the saline circulation rate and oxygen level by implementing wristwatch using IoT, Wi-Fi module. The node microcontroller platform has been used as controlling unit for providing necessary control along with Wi-Fi module and wristwatch to monitor and control. To store data related to patients, API is used which displays their history or present details in a web page of the hospital. Keyword: saline flow control, oxygen flow control, API, Wi-Fi module, node microcontroller. Introduction. The requirements for healthcare are rapidly rising with the continuous growing of the world population. Improvement in medical technology has led to the tremendous success. The main reason is the rapid advancement of sensors, microcontrollers, and computers' prompt development. Number of technological innovation systems are undertaken which lead to the improvement of medical service. There are researches and development of saline monitoring and controlling device for the betterment of people's health care. The amount of normal saline intake taken by patient is totally depends on physiological condition of patient, but normally it's between 1.5 to 3 liters per day for an adult. Oxygen flow intake is up to 2-4 L/min. Generally, in hospitals, flow level is monitored by nurses and patients' relatives. There is always a requirement to see the saline level after certain time. Unfortunately, during most of the time, the observer may forget to vary the saline bottle at correct time due to their busy schedule. This may result in several problems to the patients like backflow of blood, blood loss, etc. The existing system for flow monitoring is extremely time-consuming and inconvenient for nurses. The main objective of proposed system is to supply reliable, convenient, effortless, and cost-effective system for flow monitoring. The oxygen and saline is injected into blood by considering certain parameters like heart rate, or in medical terms pulse rate of patient. As the saline goes below the critical level, it's necessary to vary the saline bottle as well, because the oxygen flow got to monitor continuously. An automatic monitoring system determine the flow rate. Due to the utilization of IoT, the notification are often sent to the nurse on his/her wristwatch. Overview of proposed system. After examining a few papers supported the development of the automated saline monitoring system, it had been seen that a lot of complex circuit and modules were used which increase the value of producing. In some system, GSM, Global System for Mobile Communication, system, Bluetooth module, and keypad were used to monitor the system. In all the previous system it had been seen that there's no automatic control of flow. The proposed system of this paper is to detect, indicate, and control the flow rate of fluid and oxygen label accurately and give the signal to the doctor or nurse so that the amount of flow can be controlled using a wristwatch which is equipped with Node MC for transfer of signals. Usage of pulse sensor decides the amount of flow of saline and oxygen flow. The diagram of proposed system is shown in figure 1. If there is any abnormal situation like overflow or saline bottle empty, that will be indicated with the help of buzzer in the wristwatch. Sensors will be developed to determine the rate. Once pulse is detected, the device will continuously check the flow rate and maintain a normal condition. A flow sensor will detect the water drop accurately. Errors reading are often determined by signal conditioning circuit and can be removed by an isolator circuit. Fig. 1. Block diagram of proposed system. Simulation output using ProTU software. Fig. 2 depicts the simulation output using ProTU software of an oxygen and flow control system that consists of the flow sensor, pressure sensor, pulse rate sensor and LCD display. The system has been proposed using Node microcontroller platform, contains general purpose input/output, GPIO, is a pin on an IC, integrated circuit. It are often either input pin or output pin, whose behavior are often controlled at the runtime. Node MCU Development Kit provides access to those GPIOs of ESP8266. The only thing to require care is that Node MCU Dev Kit pins are numbered differently. For example, the D0 pin on the Node MCU Dev Kit is mapped to the internal GPIO pin 16 of ESP8266. In addition to this, API is implemented to display or show the patient's health details. Fig. 2. Simulation output using ProTU software. Hardware arrangement of proposed system. Fig. 3. Hardware arrangement of proposed system. Software output. A web page has been developed using application programming interface for storing the patient's health details within the hospital server. The online page using API is shown within the figure 4. The flowchart given in Fig. 5 shows the steps being undertaken for the fluid, saline, control device. At first, the pulse rate or heartbeat of the patient is determined with the help of pulse rate sensor. According to the pulse rate of the patient, one can determine the amount of glucose, saline, and oxygen level that is to be given to the patient. Thus both fluid amount and oxygen level are displayed in the wristwatch of the assist/nurse. The Node MCU in wristwatch sends signals to the microcontroller in the installed system. The level sensor indicates whether the saline bottle is empty or not. If empty, the servo motor rotates clockwise to fill the bottle. Then, according to the displayed fluid level, the saline is introduced into the patient using flow sensor and servo motor. The servo motor will rotate clockwise or anti-clockwise depending on whether there is decrease or increase in the flow that is given to the patient. The buzzer in the wristwatch of the patient will snooze when there is any abnormal situation in the flow. After the procedure is completed, web page is developed. The development of apps for mobile devices meant that organizations needed to permit users to access information through apps and not just through the web. Within the medical sector, APIs are used to allow patients to easily share information and also lets the doctors interact with patients as well. The flowchart given in Fig. 6 shows the steps being undertaken for the oxygen control device. At first, the pulse rate or heartbeat of the patient is determined with the help of pulse rate sensor. According to the pulse rate of the patient, one can determine the amount of glucose, saline, and oxygen level that is to be given to the patient. Thus both fluid amount and oxygen level are displayed in the wristwatch of the assist/nurse. The Node MCU in wristwatch sends signals to the microcontroller in the installed system. The level sensor indicates whether the oxygen cylinder is empty or not. If empty, the servo motor rotates clockwise to fill the cylinder. Then, according to the displayed oxygen level, the oxygen is introduced into the patient using pressure sensor and servo motor. The servo motor will rotate clockwise or anti-clockwise depending on whether there is decrease or increase in the flow that is given to the patient. The buzzer in the wristwatch of the patient will snooze when there is any abnormal situation in the flow. After the procedure is completed, web page is developed. The development of apps for mobile devices meant that organizations needed to permit users to access information through apps and not just through the web. Within the medical sector, APIs are used to allow patients to easily share information and also let the doctors interact with patients as well. Conclusion. Our project totally focuses on both technology improvement and healthcare improvement. Nowadays, as population increases, death rate also increases. Thus, population rate is directly proportional to death rate. There has been many technologies developed in medical field and our project can be one of them. The accuracy, size, affordability of our project can pay way to greater implementation. The prime important in today's world is reducing manpower. The repeated checking about the status of an oxygen set is reduced. Thus our project reduces manpower and increases the system's efficient.